This is testing Angular with Jasmine and Karma. In full disclosure, Jasmine and Karma aren't really covered in depth here. There's a couple talks tomorrow by Chris Bartling and Adam Eichschied, which will probably delve deeper into those two frameworks. But I will touch on the key points that you need to know. A little bit about me. My name is Zan Thrash. I'm a developer consultant for Object Partners. I tweet occasionally at Zan Thrash. I'm Zan Thrash pretty much everywhere. GitHub, Zan Thrash. All the material for this presentation is at this GitHub address. It's the source code, the tests, and some documentation. The audience for this presentation is primarily people who are new to Angular, new to testing, have some fundamental JavaScript knowledge. I'm assuming that everyone is probably in that category. Anyone that doesn't describe? All right, good. So what we're going to do today is go through we're going to test all the major artifacts in JavaScript. And this is a kind of a big undertaking to take in 50 minutes, so I'm going to go fast. If I'm going too fast, ask me to slow down. Just note that there's some stuff that might get left off at the end if we run out of time. We're going to start with testing values. We're going to move on to constants, which are similar to values. Factories, which are singleton services. Controllers, which are kind of the glue between your view and your services. Filters, directives, interceptors, and decorators. And if we have time, we'll kind of circle back to providers since there's there's some nuances to testing providers. So with that said, we're going to dive into the demo app. That's not the demo app. Let's bring it up. So the demo app is just to add context to the test, because testing these things outside of having it in context, you might not fully grok what's going on. So this is just another web weather application. We're using the Weather Underground API to search for cities and find the weather. So there's a few things going on. First thing we're going to do is dump in our API key. And then we can just search for Minneapolis, get the weather, it comes back, click on this, it gives you some more information. So well, you can see here we have a couple controllers, possibly a couple views, maybe some services to fetch. This right here is a directive with some click event binding on it. So we're going to just dive into the code to see what's going on. The first thing we're going to start with is values. Values are basically key value stores that are stored as a singleton in Angular. You could set these at bootstrap time, or you could set them later. In this case, we're using that API key from Weather Underground. And we're saving this value, and then we can inject it into other services and pull it off. So there's a couple things we want to test here. One is the state of that value when it's constructed, and the state of that value after it's been set and then re-injected. So we'll start off here. Quick. Getting everyone up to speed on how Jasmine works. Jasmine uses the notion of suites, which are wrapped into scribe blocks, and then specs, which are wrapped in an it block. So just keep that in mind. Within an it block, you make expectations of what your output is deemed to be. You could do before and after. There's a before each and an after each, which you can do setup and tear down after each test is executed. And you can nest these. So you'll see some nesting. If you have questions, if this doesn't make sense, raise your hand and I'll go a little deeper into it. So what we have, we're using Karma as our test runner, Jasmine as our testing framework. Setting up Karma is essentially, you write a Karma comp and you basically put all your artifacts that are going to be necessary to test it, and you can do some wildcard splatting. You can do plugins. Chrome Launcher will launch everything in Chrome. You could set as many browsers as you want to test it in. Phantom.js is one. Other plugins that I like to use, I like the Mocha Reporter because I think the default one is kind of verbose and kind of just vomits information at you, so Mocha's a little cleaner. And that's about it for Karma. So going back, I have a test runner. I'm using WebStorm, and it has a nice Karma test runner built in, and you could set it to just run on changes to your files. So I'm just going to set that. The first thing we want to do is in your before each, you want to set up your module. The API key module. This will bootstrap the module under test and allow you to inject via the $injector service later. So here we're just setting up our dependencies that we're injecting. In this case, it's not the dependency, it's actually the class under test. We're injecting it and setting it to a local variable. And then we're establishing what our test should be. We're testing the undefined, and we're just making an expectation that API key is in fact undefined. Some people might find this unnecessary, but one thing that I've found with unit testing in particular is that it serves kind of two purposes. One is to document, one is to test that your code works, but other is to like instantiate a contract between your intentions of what the code should do and help your future self or your teammates know what your intention was. So it's just kind of like locking that in stone, so to speak. So next thing we're going to do is test what it looks like after setting it. So we have our injected API key, and we're setting the Weather Underground API key. This is just an object that we're assigning, or a string that we're assigning to an object. And then we making an expectation on that would kind of not really serve any purpose. So we're re-injecting it to make sure that as a singleton, it comes back with the same thing. That's basically testing values. They're fairly simple. The next thing is I'm going to skip constants. Constants are basically the same thing as tests. We're using constants here. There we go. We're using constants just to lock in our API endpoints. This is the search URL. There's a base URL that we use to fetch the API, the data from. We send it the city information, and then we get back the weather information. And then conditions is just kind of a RESTful endpoint that we're kind of attending after the fact to give it a specific endpoint we're talking to. So testing these are the same as testing values. Constants is a bit of a misnomer because it implies that you can't change them, like they're immutable, but in fact there's no mechanism to prevent you from doing so, so you just have to be very careful. And I find that putting tests around these ensures that those constants don't get changed later. The key difference, and this is getting a little off topic, between values and constants is that you can't inject values into a config at bootstrap time. Constants you can. With that being said, you also can't decorate constants. So that's really the only difference. Semantically, they're the same. Next thing we're going to look into, and see if I can. Oh, resolution is awesome. Can you still read that? Is that still usable? I'll drop this down a little bit to give it a little more. So our weather fetching service is it has a couple. It does a couple things for us. It fetches. It goes and finds our conditions, and then it will either assign those conditions if something is found. Otherwise, if there's an error, we're using the $HTTP service. We're making a JSON P call. We're pulling our base API URL, which is a constant, that condition, and then our selected city, which is coming from someplace else, and we're just creating our fetch URL that way using the fairly common join syntax to just concatenate it all together. We're then calling it with the JSON P callback. We're adding some header stuff, and then it's returning a promise, which then gets resolved to either if it's 200, everything's happy, we're going to log it, and we're going to assign the response payload to a local variable. And if it's not a 200, we're going to throw an alert saying there was some sort of issue. So the test scenarios here are kind of baseline instantiation. What does the service look like? Then when we actually execute the function and it successfully comes back with the 200 response, what interactions take place and what does the state of it look like? And then if it's a non-200 response and it goes into this block, we want to assert that that window alert window alert is actually thrown. So first thing we're going to do is set up our suite. We're injecting our module. I'll get back to this in a little bit, but we're injecting a mocking module as well to kind of just clean up the test, and I'll show you that in a second. Then we're injecting all of our dependencies, so we're using HTTP backend, log, window, and we're injecting these because we want to use the Jasmine spy mechanism to inspect what's happening. And then we are getting our weather fetching service and our API key. And because we're using the $HTTP backend, which I will just now call HTTP backend from here on out, you want to, in an after each, you want to make these verifications. This will ensure that what you say is going to be called gets called, and that if something else that didn't get called doesn't. If something gets called that you say didn't get called, then it'll throw an error for you. So our first test is going to be describing when it's first created, and this is fairly simple. We want to make sure that when it gets injected that it's actually a defined object, and that its base configuration is undefined, so it's nothing set upon creation. So our next test is going to be when it is successfully called, and we're going to mock out some response data here. We're going to inject, and I'll show. We have this weather mocking service, so like creating this mocked out expected endpoint call gets kind of messy, and we're also mocking out our API key here and our mock response. If you were doing a lot of tests with this sort of pattern becomes very helpful to keeping your tests dry and you don't have to repeat yourself. So we're going to, in our before each block, because, and this might seem a bit contrived because why would you really ever want to test that your debug is being written to log, but Sometimes I was on a project where we were logging all like error and warning levels, wrapping those and throwing them back to the service to log in our systems logs to get more insight, or you can use any of the third-party APIs that will track logging for you. And so having these kind of in that implementation and saying that they are explicitly needed in a test can be helpful. Also, it lets me showcase the Jasmine spying on their spy framework, which is okay. There's better ones out there, but for the purposes of this demo, it works just fine. So we're spying on log debug, which will show those assertions later. And then we're just taking stuff off that mocked module that we created and injected earlier and binding those to some local variables. And then here's the meat of the test, where we're setting up our expectations for that asynchronous API call. So we're expecting it to be a JSON-P, and then that the URL is the one that we're setting, so it's going to make an assertion on that as well. And we want to mock out the response. So for this purposes, we're returning, we have a function that's returning an array, and the array is the status code. So it's a 200, so everything should be good. And then the mock data that's coming back that should be then bound to our local variable in our service. Then we're going to execute the method with our selected city, and just don't forget to call flush on backend, because this will actually trigger all the mock async promise handling that you don't want to do in a unit test. So that's our before each. That's just setting up the test, and then we're going to do some expectations. And I'm going to kill this for now. So here we're just expecting that the value on that service is being set to our required our response data, and that now we're doing an assertion that the debug statement was actually written with the proper parameters. And then finally, the last test scenario is testing it when it fails. So we want to test that Windows alert gets fired when anything other than a 200 or success comes back from the server. So we're going to do the same spy. This time we're doing it on window and the alert method. We're using the same helper here. We're not doing an expect, but we're doing a win. So any time that this calls, and instead of doing a function and that returns an array, we can just, if you just want to generate an error, you can just in your response do the 404, and then execute the function, flush the backend, and then make your assertion. So you can see there's kind of a pattern growing where you figure out what you want to test. You get your module in place, you inject a bunch of stuff, set it to variables, and then you start exercising it. There's some nuances across the different artifacts, which is what I'm hoping to show you here. So we're going to move on to controllers. Now controllers should be fairly, like, if you're doing controllers right, should be like stupid simple to test, because really what you're doing in a controller is you're doing state-based testing and you're doing interaction testing with collaborators, mainly your services. You should really not have a lot of business logic in your controllers if you can avoid it. You can't always do that, but best practices is fire off some function, have it delegate to a service, and then have your view react to that data change. So here we have a search, which is taking a query from that input, and it's doing a kind of a type ahead search, returning an array of JSON objects. And then once you have your city in place, we're doing a find condition. So we're testing these two scenarios. Oops. So again, we're setting up our top level suite. We're injecting our controller module. And one thing to note, I failed to mention it before, is for ease of testing, the module system really comes into play. I tend to do one module per file, and this allows for isolation of tests, so you're not like Bootstrap having to test and mock out all of your HTTP backend calls for a Bootstrap template fetch for something that has nothing to do with that. That's just I'm not saying it's the best practice, it's just one that I've found works well for me. So here we're going to inject the controller service here, because you can't inject controllers. You have to instantiate them. They're not services like a value or a constant or a factory or a provider or a service are. They are instantiated when needed, and they're not singletons. So we're gonna inject the controller service will allow us to instantiate our search controller, and then we're just binding that to a local. You might have seen examples that use, like, you have to create a scope, and then you have to test all of your functions off of the scope. And for this example, I'm using the controller as pattern, where in your controller, we're just hanging everything off of this, which gets wrapped in the scope down the line, but you don't have to inject scope into your controllers at this point. It's been around for a bit, but if you read the documentations and all the testing, you might not see it written this way, but it does make testing your controllers a lot cleaner, because you're not instantiating your controller, setting the scope on the controller, and then executing everything off of the scope, which I always felt a little kludgy to me. So this way you can just create your controller and then execute everything off of that. So we're gonna test calling that search with the search function with a query. We're gonna inject our search service into our test, and we're just gonna create a spy on the find info city, which is what gets delegated from that controller. And we don't really care what gets returned, so we're just creating a dummy object. And then we're going to do some assertions, and then we're going to exercise the controller and do some assertions on it. So we're just passing in Minneapolis, and we want to make sure that the city search service that we're using gets called with the appropriate variable. So it's fairly straightforward. And then the next test will just be doing the same thing, but for the other function on it. So same pattern, create our suite, inject our collaborators, set them locally, wrap them with a spy, write our spec, set some default state that this function happens to take off of itself. So it's just using that selected city that we're setting on the controller, and then make sure that your collaborator is getting called. And that's controllers. Fairly simple. kind of use it as a litmus test is if you find yourself injecting $HTTP backend, or which I said earlier would just be called HTTP backend, into a controller test, you're probably doing something a bit wrong. You're going too deep down the rabbit hole. You just want to test no more than one layer past your class under test. So just keep that in mind. Next one we're going to do is filters. Filters let you take some input and create some output. They're basic I/O. They shouldn't do anything fancy. They can, but you want to be limited. I've seen people put an input in wrap a bunch of HTML tags around it, which works, but it's kind of bad practice because you completely limit it to the view. Filters can be used all throughout your code if you just need a nice tool to change something to something else. So for this, in our demo, I still have it up, you can see that we're kind of creating this nice little human readable output. And basically from our API call, we get the epoch time since it was last called. So we are just taking that input and we're using the moment.js library for time, which is a very nice date time library in JavaScript. And this from now will create a human readable output. So our test is fairly simple. You can go as extensive as you want or need for it. So again, setting up our suite, creating our module to bootstrap that module. And then, like controllers, you can't inject a filter. You have to instantiate it with the filter service. So we're injecting the filter service here and then calling our filter, which will set it to a local variable. And then we're just setting the current time as now, and we'll just use that as kind of our baseline for testing. So you basically just, once you get your filter local variable, you just execute by passing in whatever your input is and asserting that your output. So right now, it should come back as a few seconds ago, assuming this test runs within a second or two, which it should. This test should always pass. Again, using the moment.js library, we're subtracting 2 minutes to test that now, minus 2 minutes is 2 minutes ago. And the same for 3 hours. Goes deep down the rabbit hole on this, so you want to get a feel that your code is correct. And that's testing filters. Pretty simple. I'm doing for time. All right. Going fast. So next we're going to cover directives. In directives, I could have probably done a whole talk or two on testing directives. So this is a very contrived directive, but it definitely, the key takeaway here is just to establish the pattern that you need to implement to test directives. Because there's a lot of, well, we'll just call it magic going behind the scenes when directors render and all the dispatching, and I don't have time to go into that. But so, whoa, that is. All right, let's try. Is that still readable? More or less. So our directive is basically taking the input from this search. When you call the get weather, it's getting a JSON object, and then it's setting it in scope on the search controller. and then we are passing it into the directive. I'll show you. So here's our directive. So because we're using the controller as pattern, we can namespace our controller scopes, which is another benefit of it. There's search controller, and then there's a weather. There's a weather variable that's on scope, and then we're just getting conditions off of it and passing it into the directive, which keeps blowing up. So there's a couple things we're testing here. We have an ng if there are search results for that directive, then render the table. If not, don't render the table, is basically what we're saying. And ngIf will, if it comes back false, will just not render those DOM elements, so we can test for that absence of children. And then, so we have two cases, if there are results and if there aren't results. So again, setting up our spec, injecting our module, our instantiating our module, injecting all of our variables, our collaborators. Here we're injecting root scope. You pretty much need to do this all the time for testing directives. That's a key takeaway here. And because we're binding on the click event of that directive to kind of just pop up alert. This is to test to see how you test eventing in directives. So our first spec is it shouldn't display the results if there are no search results set on the directive. So the first thing we want to do is use this Angular element function and pass in the DOM representation, basically the HTML of what our directive would look like if we were to set it on a page. We're then going to assign that to an element, which we've defined up there. The compile service that we put in actually will take that element, do the same directive compile that would happen in the browser at the time of rendering, and then we are also which returns a function which we're then immediately calling with the scope. And we haven't set anything on scope, so this should not be set. And then we want to call digest, which will then do all the binding for us if needed. And then we're just doing an expectation that the element, which is this will actually return a DOM object that we can then use either jQuery Lite, which comes for free with Angular, which is like jQuery but very, very stripped out. So we're just checking the element, seeing that it has no children basically under it. So that's our no results found test. And then when we do have results, we want to make sure that that table is getting rendered. So again, we're injecting compile. Before each, we want to spy on the window alert for when we test that click event at the bottom. And now we have results that we want to set on scope. And this doesn't need to be the same results that are set in your actual, because this scope is backed by a service at runtime. You don't need to do that per se. You can use whatever variable you want, just as long as you set it appropriately when you compile your directive. So here we're setting our search results as the scope results, calling compile with scope to render our DOM tree, calling digest to do all the two-way binding. And then we're just going to do some expectations, make sure everything is where we assume it to be. One thing you'll find, especially if you're doing, if your template in your directive has like multiple levels like this does, it has, various table elements that's going down. jQuery Lite is just not going to probably cut it for you for quickly getting those elements via selectors, because you could basically only select off of tags. You can't do IDs or classes or anything else. So if you want to use jQuery, full-fledged jQuery in testing, that's usually okay. It's still kind of frowned upon to bring that into your Angular app because it's just adding so much weight that you probably aren't going to need. You can go to Karma Conf, and if you put jQuery at the top of your files, that'll override all DOM selection that jQuery Lite. It just delegates directly to jQuery for you. So then you can do finds by IDs here. Otherwise, you have to do like children. It gets ugly fast. So just keep that in mind. It's available. And then we want to test our trigger handler. So you just take your element, and whatever element you bound that event to, you just call this trigger handler and the event, and it'll fake that out for you, and then fire the and then we're just doing an expectation that our window alert was actually called with the right data. So the directives are they're Swiss Army knife of Angular, and there's probably 1,000 different scenarios that you can test in your directive, but this is still kind of the pattern that you should take away. You need to create your element and then compile it and then call scope digest. Just lather, rinse, repeat, make assertions. We should be good. All right, so we're going to move on to interceptors. So interceptors let you basically intercept all AJAX HTTP calls and the responses. So you can hook into that call chain, and you can either like add header information if you need to do it on everything, or if you want to change the body, you can get pretty fine-grained in there. So for this example, the Weather Underground API is a nice API for weather, but one thing they kind of don't do, in my opinion, correct is error handling. If you make up a call and they throw back an error, they will throw it back with a 200 status code with an error in the response body. So this is kind of a good use case for interceptors. Interceptors are just services. So this is a factory service. You see here we're calling a factory, calling this function, creating it just like you would any other service. But you can hook into those events by just overriding basically a function. So overriding a response will let you hook into what comes back. Response error will let you, if there's an error thrown, you can hook into that. And there is also there's request and request error. I kind of commented those out since we're not really dealing with them. And because this is a response that is throwing a 200, we want to inspect the response for that error payload. It's super hacky, but it's a nice clean way to do it, so you're not putting this code everywhere in your app. So what we're doing is we're just checking to make sure that the URL, if a response comes back with a config with the URL that made the call. So you can check for that, so you're not executing this code for every response, because this will execute for every response you get. So template fetching, CSS fetching, everything will go through this. So you want to kind of put some limits on it. And then we're just checking if it has response, if it has response error, and then we're going to trigger an alert if there is actual an error description. So our testing is there's kind of three tests here. One is if you have an error with the appropriate URL, if you don't have an error with the appropriate URL, and if you just every other URL but the one you care about are kind of the three areas we want to hit. So we'll just breeze through this. Again, setting up your module. Setting up. So one thing, this is old code. We don't care about HTTP backend. You don't need to worry about actually stubbing out an HTTP call to test these. You can just test the method exactly right away. It's probably the best way to do it. If you really want to ensure that interceptor is happening, like an end-to-end test is probably a better solution than this. You don't want to have to, trust me, just do it this way. So here we're just making sure that our interceptor is actually created. And then we want to check if there is a response with an error from the API. So we're going to spy on that window alert because we're expecting that to trigger if there is an error. We're just basically building out our response object that we're going to pass to it once we call it. So this is our function under test, passing response. And then our expectation is that the window alert was actually called with the error that came back. So fairly simple. Our next one is without an error. So it's from the same API endpoint, but it's just standard, like good request with no error. Same pattern. Same pattern. We want to spy on alert, set our config. This time we don't have an error in our response, and then execute. And that we're just making an assertion that the window alert was not called. You can negate all. In Jasmine, you can negate all assertions with a not. And then finally, if there is no, if the API is not one we're concerned about, if the response URL is not one we're concerned about, so this is the non-API one, same pattern. And again, that it's not called. Ooh. All right, so we are doing okay on time. I'm going to go through decorators real quick. I don't think we're going to have enough time to get to providers, but if you want to know about those, just hit me up afterwards. Otherwise, all of the code is on that GitHub account, which I'll tweet out, and it's on all the Midwest.js documentation GitHub repos that are available. So decorators are kind of, I found a lot of people don't know about decorators or just haven't dug that deep, but they're super cool. They let you basically augment existing services, whether it's core JavaScript services. Sometimes you're using a third-party service that you want to monkey patch, but you don't want to or can't help the person fix the issue, or the person just won't fix the issue for you. You could decorate pretty much anything that you can inject other than constants. So for our example, let's see if I have. I decorated the log debug. Don't pay attention to the errors. To just put a timestamp in front of it. might be useful. I don't know. But basically what you're going to do is you're going to inject provide, which is provided all the services that are created use provide under the covers. It's just the normal constructs that most of us use are just wrappers around that. So this is a little raw, which is maybe why they're not well known. But you just do provide.decorator, and then as a string, the service you want to decorate, you will then get a delegate, which is the actual service that you're decorating. So you can hook in like before or after, kind of do some point cut additions, or you could do wholesale replacements of functions. So we are doing an enhanced debug where we're taking the arguments, slicing them into an array, again using the Moment.js framework to create a timestamp with this format, hour, minute, seconds, AM, PM. And then we're just prepending that to the first arg. And then we're just passing the args back to the delegate. So log still works, log debug is still working the same way. We're just kind of hijacking that call and injecting our own behavior. And then you just return the delegate. So they're fairly easy to test. Debug, the log one is a bit I'll just show you this one. So the log one is a little bit quirky because to test it, you're actually decorating the mock log, and there's really no good way that I was able to find to get the actual log implementation in a test. It's just the way the mocks work. It's the last one, the last singleton that's created is going to win, and it's just always going to win in the testing scenario. So the way it works is instead of logging to the console, it logs, it takes your log and pumps it into an array. So what we have to do here is create an array. So just calling .log reset will create that array for those logging statements. And then we can just test that the first item in that array matches, and we're just doing a regex because you don't want to, it's date and time, you don't want to have to your test be that fragile. So this will ensure that your logging works. So I have 10 minutes, 2 minutes, I have 2 minutes, perfect. All right, I am going to wrap there. Again, if you're interested in providers, which you should look into, the reason I took them out is because like day-to-day operations, you're probably not going to be writing a lot of providers unless you're writing like a framework or a library that's going to be reusable across multiple projects, but just project work, you're probably not going to do it. But the examples are at, they're at my GitHub, which is just Zan Thrash. It's the yet another, it's in the slide deck, yet another weather app. It's all there. It's annotated, kind of annotated. There's some notes, which are half thoughts really, but kind of, you could, I feel that this could be a decent reference implementation for testing all Angular aspects. So if you see something you don't like, send me a pull request, hit me up on Twitter, and we'll build it out there. That's all I have. Thanks for your time. Any questions? All right, enjoy the rest of the conference.